In this video, I will discuss the past strategy for the subject Computer Organization and Architecture 2019 scheme. So we can see the module-wise strategy. From module 1, the important questions are, first one is single bus control sequence. So you will be asked to write the control sequence for an instruction like add R1, R2, sub R3, R4. Learn the step-by-step T1, T2, T3 sequence for fetching and executing. Then second question it is addressing modes. Learn any 4 to 5 modes: immediate, register, direct, indirect, indexed, with one example each. Then part A questions from this module are big endian versus little endian differences, 0 address, 1 address or 2 address instruction examples. Then coming to module 2, processor logic design. First question is 4-bit combinational logic shifter. Designing a 4-bit shifter with control variables like H0, H1. Memorize the circuit diagram and function table. Second question is status register. Learn the block diagram for an 8-bit ALU status register. Then third question it is scratchpad memory, block diagram and explanation. Part A questions are register transfer logic. Then coming to module 3, arithmetic algorithms and pipelining. In that first question it is the Booth's algorithm. Learn the flowchart and practice tracing a numerical. Second question is restoring diffusion algorithm. Learn the flowchart and practice tracing a numerical. Then pipelining hazards. Learn data, structural and control hazards and how to resolve them. Then array multiplier. Learn to draw the block diagram of a 3x2 or 4x4 array multiplier. Then coming to module 4, control logic design. In that first question it is microprogram sequencer. Draw the block diagram and explain the address sequencing capabilities. Then hardwired versus microprogrammed control. Learn the difference. Learn the basic block diagram of hardwired control. Then horizontal versus vertical micro instructions. Just memorize a 4-point comparison table. Coming to module 5, input output and memory organization. First question it is cache mapping functions. Explain direct, associative and set associative mapping. Learn the block diagrams. Then direct memory access, block diagram and the difference between cycle stealing and burst mode. Then difference between DRAM versus SRAM. Why does DRAM need refreshing? What is the cell structure? Then interrupts, sequence of steps the processor takes when an interrupt is raised. Now we can see a plan of study. So first you can conquer the algorithms. First, the two algorithms, important algorithms are booth algorithm and restoring algorithm. Then solve 2 problems of each on paper and draw the tables. Then second thing is computer architecture is a visual subject. So you have the diagrams are very important. Practice drawing these 4 diagrams. Microprogram sequencer, 4-bit combinational shifter, status register block diagram, single bus architecture, data path. Then control sequences and memory. Learn how to write step-by-step control sequences for add or sub. Memorize the block diagrams for the 3 cache mapping techniques. Then write down the differences between SRAM, DRAM, DMA modes, hardwired or microprogrammed control. Then go through the part A questions. Then if you have 2 to 3 line definitions for big endian, small and little endian, RTL logic, instruction formats and memory mapped IO, these are all important. Thank you.